Okay, dear students. So in this video, we are going to learn about the topic of significant figures, and we would be discussing everything, whatever is in your syllabus and whatever is required for your examination. Okay. So first of all, let us understand the concept behind significant figures. What are they, and why do we use them? So significant figures comes into picture when we make some measurement of something. Like for example, you want to measure the length of your cell phone and you want to see like what is the length. And if I ask you, how would you be reporting? You would be reporting like somewhat like you will say 5.362 centimeter or whatever. Now that will depend upon the scale that you're using. So up to what decimal can you measure? For example, the scale here, this is a centimeter scale on your screen. And if I measure here, so obviously I can move from one point to the another point, but there is a big gap between the two measurements. But in this measurement that I have reported, 1 millimeter is not the minimum count. It is going even beyond that, isn't it? Because the values are for three decimals. So this is very, very specific and very, very precise. Now, how the significant figures are defined? Significant figures are number of those digits in this reported value for which we are particularly sure about them. The digits which are 100% accurate and we are sure about those digits. So those digits are called significant figures. In this the centimeter scale that I have shown you, let us take one particular example. Let us say you measure something and the measurement comes out to be 1 centimeter. Now if I say that no, it is exactly 1 centimeter, and my scale, the least count for the scale is 1 millimeter, that is known as least count. So least count is the minimum value that can be measured with the help of a scale. So in our case, it will be 1.1 millimeter or zero point 0.1 centimeter. So I can very well say that no, I am sure about it. It's not 1 centimeter, it is 1.0 centimeter. Because I'm sure that after decimal it comes out to be 0. That is why it will be 1.0. So if I make another measurement for another thing, let us say I go up to this level. So now my measurement is coming out to be 1.1 centimeter. And you say that I am 100% sure about my measurement and it has to be 1.1. It is not 1.0. It is not 1.2. It is exactly 1.1. So how many significant figures are there in this figure? We will say 2. That's obvious. But what about a measurement that lies in between somewhere here? Like for example, I make this measurement and this measurement falls in between this. So now this third case, I would say now the length x, it is, I'm sure about this thing that it is more than 1.1 centimeter and lesser than 1.2 centimeter. Yes, but I am not sure about its value. So as per the scale is concerned, the scale that was provided to me by somebody, I will say I think the value is 1.1 centimeter. I will go with it because the rest of the value is very less, so we can neglect it. But that is not the right way, no. So the value can be, in this case, it can be 1.15, it can be 1.17, it can be 1.14, but I am not sure about it. It means this last digit, I am not sure about the last digit. So in this case, if I say that I have a super scale in which I am measuring even beyond millimeters, so in this case, I am not sure about this too. It can be 5.361, it can be 363 or something. So this 2 is a doubtful digit. This is the situation where the topic of significant figure lands. It comes into picture. So what is happening is significant figures are number of digits that in the reported value, the number of digits for which we are pretty sure about them. Like these digits are supposed to be there in the measurement. We are 100% sure about them. Those digits are called significant figures. We move to next video now. Okay, so the next thing is how can we find the number of significant figures in the reported value? So there have to be some rules that we can call these values as significant, these values are not significant, and what are they? So rule number one is that all the non-zeros are significant. Okay, so all the non-zero digits will be taken as significant. So if I take the example of, like, let's say 50304, so I'm definitely sure that there are three significant figures. I'm not sure about the zeros though, but the non-zeros are always significant. Rule number one. Rule number two is all these zeros which are included in between two non-zeros, they will be taken as significant. So we are considering these zeros also. So how many number of significant figures are there in particularly this example? 1, 2, 3, 4, 5. So there are 5 significant figures in this number. 3 are non-zeros, 2 are zeros which are included in between the non-zeros. They will also be included. So there are 5 significant figures particularly for this example. Now let us move to the next rule. So here you can see 504 is having 3 significant figures. Okay. Now, what about this kind of thing? So the zeros at the end of the integers do not count. The zeros at the end do not count. So simple, if you're having the example of 608,000, so these zeros will not be counted, but this zero will be counted. So there are 3 significant figures particularly for this example. Okay, now point number 4. Now this is like 200. This is a very simple example. Given the number of significant figures is 1, and these zeros are again not included in our calculation, but there is a catch. I tell you, for example, if I say that the number is 200, so definitely the significant figure will be equal to 1. But if we say that we have precisely calculated the thing, and if I ask you like how much time will the process take, and you say that the process is taking 200 seconds, now 200 in these zeros are significant because we know that it has to be 200. So these zeros become significant at that moment. So the significant figures here become 3. Yes, I know that the rule is that the zeros coming afterwards will not be included. This is absolutely correct. The significant figure should be 1. But if I say that no, I made the precise calculation and I say that the measurement is 200 seconds, it means significant figures will be 3 now. So this is a special case, I would say. Now moving next, point number 5. What is that? All the zeros before this are not counted. So zeros in front do not count. So zeros in front do not count. Obviously these zeros do not have any value. So these zeros also do not have any value. These zeros also do not have any value. So there is a rule that if you change the unit of a measurement, the significant figures do not change. So whether you multiply by 1000 and convert meter into millimeters, even then the number of significant figures will not change. And if you divide something by 1000, even then number of significant figures will not change. They will remain the same. Okay, so the point number 6, this example, so these zeros will be included. Now this thing I would say, so decimal 0.05900, so these zeros are coming out of our measurement. The same principle that I have used here, the same principle is used in this case now, because these zeros do tell about our scale, that you are using a very accurate scale, and so that you can make a precise calculation. So that is why these zeros will be included in the count. So overall, there will be 4 significant figures in this example. So my dear students, these are the rules for the significant figures. Okay, so now I think with this, the rules for all these things will be pretty clear to you. Like, what are the rules, how to choose the number of significant figures. Now, there is another thing, and we talk about this scientific notation that is written here. So, what are these scientific notations now? You see, here we knew that there are three significant figures. So, in the scientific notation, what we do is we show that we are having only three significant figures. So, these are the figures that were known, and others have been written as 10 raised to power 2 because we do not actually care about them because they are not significant. That is why we will just club them into a raised to the power 10. Now, this value that is 60800, here are three significant figures. So, my answer should be given in three significant figures only 6.08, and every else thing can be clubbed into 10 raised to power 5. So, similarly, here is one significant figure. In this last case, there are four significant figures. So, we have given four precise values, and we have written 10 raised to power minus 3 along with it. Now, you say, I am so much sure about my calculation, and I was able to calculate, I was able to measure the thing up to four decimal places. My scale is that big. My scale is working at microscopic level. So, microscopic level, I'm saying that I know the value is exactly zero. So, this value is known to me. That is why they will be considered as significant values. So, this is how we convert these values into scientific notation. So, this is very, very important, and you must know how to write these values. Okay, this is very important now. So, now closing this part here, so what is the next part? The next part is about the calculations. So how do we do that? Okay, so in this part now, let us move ahead now. We are going to find how are we going to calculate the values when we are supposed to give answer in particular number of significant figures. So there are two things here. Number one is addition and subtraction. And another thing is multiplication and division. Multiplication and division. So first of all, we will consider multiplication and division in this case. So what is happening now? Let us see. So there is a very simple rule here that in multiplication or division, the result must be having as many significant figures as the least precisely known number. So it means, like, let us say we are multiplying 23 with 578 now. So we know that number of significant figures here is 3, and here the number of significant figures is 2. So my answer, whatever it is, which is coming out to be 13294. So I have to give the answer in a perfect manner. So what I will do is I will try to report the answer in only two significant figures. How that can be done? So I have to give only two significant figures. So it will be 1.3 into 10 raised to power 1, 2, 3, 4, 10 raised to power 4. So this is going to be my correct answer. Now, why is this done? What is the importance of this? Importance of this is that you do not know this thing to three significant figures. So you are not sure about it. For example, we want to find the area of a rectangle, and you say that okay, this is the length and this is the breadth. So what will be the area? Area is length into breadth. But the problem is that you have not calculated or you have not measured the length in a correct manner. So your measurement for the length is not precise. So the precision for the length is different from that of the breadth. So if you find the area of it, how can you be that sure about what is the area if we're talking about very precise calculation? For example, if you talk about the number of pixels in your iPhone, so you purchased iPhone 14 Pro and you see that number of pixels in your cell phone and the number of pixels in the cell phone that your brother or sister has purchased or your friend is having, number of pixels are different. Like they are having more number of pixels than you. Is it possible? So this thing does not happen. You know why? Because the iPhone manufacturing company, they use these significant figures, no? So they know the calculations have to be precise. So they go for even decimals. Like we should be as precise as much as possible. Okay, so that is why here the answer is reported in a least number of significant figures, that is 1.3. But in the case of addition and subtraction, that is not the case. So when we add them, so let us say I am adding these two now. Let us say I am adding these two. So what is happening now? This is adding now. So if we are adding them ever, our only rule is that the decimal point should be same. We are now not concerned with the significant figures. We are now concerned with the decimals. So this is having two decimal places and this is having only one decimal place. So your answer will be having one decimal place. So you have to drop the second one. This 7.32, this 2 is not required. So it will be 7.3. Got it? So we have to report our answer up to one decimal point only. Now the question is, if you have the value of 7.32, it is written as 7.3. Now this process is known as round off. So round off is the process with which you try to reduce the number of significant figures of the actual answer into uh, the answer that you must give as per the significant figures are concerned. So you have to reduce your significant figures. So how are you going to do that? So that process is known as round off. So we would be doing it in the next video. In present video, we have learned that in the case of multiplication and division, it is minimum number of significant figures up to which we report our answer. And when it comes to addition and subtraction, it is the minimum number of decimal points. So how many decimal points are there? According to that, we give our answer. Okay, so let us move to our next video now. Okay, so now we consider the another topic which is very important, and that is rounding off. Okay, so that is not explicitly mentioned in the book, that it is completely different topic, but it has to be done also. So what do you do to round off things now? Okay, so it's a very simple topic. Only one rule is a little complex here, but other all rules are very easy now. So what is happening here? You see, so if we are having this example in front of us, like 5.428 something, 4248. Okay, and we want to round it off up to two significant figures. So we have to, it means keep only this and we have to delete this much thing. We have to ignore, that is 248 has to be ignored. So what do? We just see that after 4, what is the digit? Like for example, in this case, it is 2. If this 2 is lesser than 5, that is the next digit is lesser than 5, we just drop the things together. So this thing will be rounded off into 5.4. Simple. Now if instead of this we had 5.4638, and now we want to reduce it into two significant figures and we want to drop 6, 3 and 8. So in this case, because this digit 6 is more than 5, this preceding digit will be increased by 1, so our answer will become 5.5. Easy. 5.5. Now another example. Now let us say I have this value 5.4, instead of 4 this is 5, and now it is 2, 3, 6. Okay, so what are we going to do in this case? Obviously we will break it from this point, and now this digit is lesser than 2. Okay, lesser than 5, so this will become, it will be rounded off as 5.5 only. So that point, because 2 is lesser than 5, it will be skipped. So this is okay now. So let us move to next example. If we are having 5.25, yeah, 5.25 3, let us say this, and we want to reduce it to significant numbers 3. So we want to drop this number, so it's very easy. It will become 5.25. This is known to us, but the problem is if instead of 3 we have 0, 5.250, and now we want to reduce it to three significant figures only. There are four significant here. So we want to drop this 0. So what are we going to do in this case? Now here we have a rule which is known as odd even rule. Now what is that? If the preceding digit before 5 is even, like we will say 2 is even, so we are not going to change any of the digits, so our answer will be 5.25. But if we are having the example 5.350, in this case, because 3 is odd and we want to drop 0, it will be increased by 1. That is, 3 will be converted into 4. So our answer now will be 5.4. 5.40. Do you see that? Now, the number of significant figures are 3, but what we have done is we have just increased that digit. This is completely, people might feel that this is completely irrational. Why are we doing this? And what is this thing, odd and even? This is not based on any scientific thing. Might be, but this is the rule and this is how we do it. So these are the rules that you have to follow to reduce the number of significant figures, because your question will be that if this is the length and this is the breadth, you need to find the area and provide the answer in suitable number of significant figures. So at that time, you have to use all of these rules. So my dear students, I can tell you my experience for solving IB question papers. This much knowledge is enough for you for this topic to do all the questions from this particular topic. So this is Professor Varun. Please subscribe to the YouTube video, subscribe to the YouTube channel, and also share the YouTube channel with all your friends. All the best.